I'm really glad to be back at this year's Current with this lightning talk. This talk's origin actually is about a little side project that I was doing during the past months or so. It's called Kryptonite for Kafka, and what it essentially does is it provides client-side encryption on a field level for applications that talk over Kafka. The specifics don't really matter. There is a core library that does some cryptography stuff, and then there are wrappers on top of it to conveniently apply encrypt, decrypt operations on data. For instance, there is a single message transform to do that. And so at some point, I thought it might be useful to have the same cryptographic functionalities available as functions for Flink SQL and Flink's table API, so that you can encrypt and decrypt fields from tables, basically. So we see two simple examples here, a SQL statement that calls that encrypt UDF on some sensitive piece of data, which is a social security number here. And then we see the corresponding decrypt function called from some Java table API code. And as I was experimenting with this, I learned a few things, and this is what I tried to distill into this short talk. So I'm going to cover briefly the following 6 implementation aspects that, in my opinion, matter most when you start working with UDFs on your own. So when you build on top of any Flink release and start to build things in its ecosystem, such as writing UDFs, it all starts basically with being aware of the Java version, or Java versions, I should say. Talking about Java versions, so there are different releases of Flink suggest or require different versions of Java. So there is JDK 11 support for quite some time, which is hopefully then allowing you to use that as the lowest baseline for your own projects. If you have newer versions of Flink, of course, you can use newer versions of the JDK as well. There is, I think, JDK 21 support underway, but usually it's still early stage, so typically you decide between JDK 11 and 17. Now, 2 aspects that matter when you start implementing those UDFs. The first one is a classic version mismatch. Let's say you only had the best intentions and you wrote your UDF with JDK 17 in mind, and then somebody came along and tried to use that UDF in a Flink cluster that expected Java 11 as a runtime. Unsurprisingly, that won't work. That gives you an unsupported class version error. There's another aspect that I want to briefly mention in that context, slightly more tricky, I guess. Let's say your UDF is implemented with JDK 11 and works fine, and then JDK 11 and then works fine, fails when you try to use it with JDK 17. There can be different reasons, but chances are that this is somehow related to the strong encapsulation and modularization that is enforced as of Java 17. In my case, for building these encryption functions, this was actually the case because the underlying building blocks, they are using a bunch of encapsulation violating operations, and so I had to make use of some of these JDK-related flags. So if that's applicable to you, familiarize yourself with these because they allow you to work around those problems that might be related to that strong encapsulation. So the bottom line of this is know your Java runtimes, and it's very rarely the case that a UDF is only meant to work for a specific Java runtime. So ideally, your development and build processes can support that in a way that your UDF can be used with multiple releases of Flink and versions of the Java runtime. Second aspect, type inference, very briefly. So this is an important topic because the Flink table API and Flink SQL are strongly typed. That means for your UDFs that you implement, that you have to make sure that all those calling parameters and the return value of these functions are properly mapped to supported Flink data types. There is 3 possibilities how this can happen. The first one is reflection. So basically, you don't really do anything in particular about it. Flink tries to figure it out automatically. So here on that snippet, we see a simple example, an encrypt UDF that just has one evaluation method, accepts a string as a parameter, and returns a string, which then would be the base64 encoding of the actual ciphertext that you would get from encrypting the data. Another option is to use annotations to provide type hints to Flink and help Flink understand how it should interpret and deal with the types, both parameters again or return values. Here we see another example that annotates an evaluation method that has in Java code just the object type, which basically means you can use this function with any supported data type, but for that to work, we need to have that type hint annotation. Otherwise, the Flink engine would not really know how to or what to do about that parameter, because from the object type alone, it cannot derive anything by means of reflection. Finally, if this is not enough, sometimes you have more specific needs, and if that's the case, you can use programmatic type inference in your code, which then allows you to implement basically arbitrarily complex type inference for the input and output types of your UDFs. An important aspect to remember in that regard is that as soon as you do that, the other mechanisms are effectively disabled. A few words about overloading. So we just saw examples with a single evaluation method, and this is for scalar functions in Flink by convention also the bare minimum that your class must provide. So one public eval method, otherwise you get a runtime error. An interesting aspect that I just recently figured out is that as soon as you start to use overloading more, probably more than usual, in the sense of you have a dozen or more overloadings for a single class, it can lead to noticeable execution delay before the job can actually start. Here we see an example which uses in total 14 overloaded methods in that single class. 12 are not shown here for reasons of space. And that already was enough to make the program execution hang for almost a minute. And this is consistently reproducible. I just figured it out recently when I started to add multiple overloadings for those encryption functions. I'm not 100% sure why that is, but I assume this could well be a bug. I will definitely dig deeper about that. Finally, determinism, another important aspect to consider. So a user-defined function signals its calling semantics to be either deterministic or not. In simple terms, that means you hand your UDF the same input, it always gives you the same output. And that is assumed by default. And as a consequence of this, the engine might do some optimizations, which means if you call a deterministic UDF with just a constant parameter or constant expressions, it could be optimized away in the sense that it is only called once during planning phase, and then later during actual job execution, it just reuses that and doesn't call it on every single record of, say, a Flink table anymore. If that is not what you want or need, you need to signal non-determinism by overriding a specific function to return false. Again, something I needed for my encryption use case because cryptography usually relies on some randomness, and so I had to prevent that optimization from happening. Otherwise, what would happen is that the engine, if it optimizes that call, we would see repeating sequences of ciphertext which could potentially leak information. Configuration, some UDFs, they need, say, initialization or bootstrap code. They may need external configuration in order to influence the behavior of the function from the outside. And for that, you can override the open method, which then allows you to access this function context of a UDF, where you can then retrieve Flink job parameters, or you could just use environment variables directly in that initialization code. Lastly, testing. Testing, I hope we all agree, is equally important for writing UDFs than for any other piece of software. I think the bare minimum should be unit testing, and here JUnit 5 features are coming handy because you can use, for instance, features such as parameterized tests together with different sources for generating the calling parameters and defining the expected return types of such functions. Integration testing is also not difficult in the sense that you can use it conveniently using JUnit 5's extension mechanism. You can use the so-called Flink mini cluster as part of your test. And this allows you to basically bootstrap Flink as part of your tests. And after that, you just basically prepare the execution environment for Flink, register the UDFs under test, and then you come up with the actual test code that prepares typically some sample data, calls the UDF, and then verifies the results. If you want to go beyond that and do end-to-end testing, test containers is very, very handy because you have different ways to define your environment that you need for running those end-to-end tests. Here we see a simple example that uses a compose container on top of an existing YAML definition. So a compose file defining at least the job manager and task manager and potentially more services that your end-to-end test wants to use. The rest is strikingly similar to the integration testing, with the only difference being that your actual code refers to that test containerized cluster by using or creating a remote execution environment rather than a local one. And that's about it. So I have a basic UDF's example repo that you can look at to dig a little bit deeper. It's intentionally kept simple, but it addresses all the related aspects in that talk. It is not related to the encryption use case I had because it would distract too much from the actual discussion and just overcomplicate things when you look into that for the first time. Other than that, if you want to chat afterwards, we might not have questions here on this lightning talk, come to our booth. We are still there until the end of the day. And if you have some time left, I highly recommend you, if you want to learn a bit more, this talk from my colleague and excellent speaker, Robin Moffat, talking about the joy of jars and other Flink SQL troubleshooting tales at 3 p.m. in this very room. With that, thank you so much for joining. I hope that was useful and helps you to start working with UDFs and hopefully save some precious time. Thanks for showing up and have a great rest of the day.